Alright, so today we're going to talk about lessons 9.1 and 9.4. 9.1 is the systems of linear equations, which is pretty straightforward. You've probably already seen this. Linear equations, we're talking about straight lines. So if you have straight lines on graphs, and the system means multiple graphs at the same on the same axis, right? So if you have a set of axes and then you have lines on that axis, I mean, maybe you have a line like this, maybe you have another line like this. Well, they intersect. The intersection points are the solutions to systems of equations, or systems, yeah. But there are three situations that you can have when you're talking about a linear system of equations, right? You have, and here's some pictures to model that. So you have either you have two lines that intersect only one time, because they're straight lines, they're not going to come back and intersect more than once. So in this situation, you have one solution, right? And then you might have two lines that don't intersect at all, meaning that if they don't intersect at all, they have to have the same slope but different y-intercepts. Here, there would be no solution. And then you have an infinite amount of solutions, meaning that these are coinciding lines, right? They're the same exact line, which one line is there and the other line is there, right? They're just over top of each other because they're the same line. Then there's an infinite amount of solutions. So today I'm going to show you how to, determine this and how to solve these on your calculator. That's the goal here. We're not going to do it by hand. We're going to do it on the TI-84 calculator. All right, so one solution, no solution, and infinite numbers of solutions. So I guess I'll kind of give you, when you have one solution, you have different slopes. When you have no solution, you have the same slope, but there has to be a different y-intercept. All right, same slope, but the y-intercepts are different. For coinciding lines, it's the same line, right? Which means same slope and same y-intercept. All right, these are called coinciding lines. All right, so let's get started. When I see this, and now it says solve by the substitution method, we're not going to do that. We're going to solve these by graphing. But in order to get them to the form we can graph, first we need to solve for y in both of these. So we're just saying, for this, I guess I'll say 3x plus 2y equals 11, right? So first I subtract 3x on both sides. And I guess I should have said this a minute ago, but in case you don't remember, the form that I've taught you that we're going to try to deal with of a linear function is y equals mx plus b, right? M is your slope and b is your y-intercept. So that might come in handy. So we want to get it in this form. So first we subtract 3 on both sides, 3x on both sides, and then we write 2y equals, now I want to put my term with an x in it before my term with no x. So minus 3x plus 11, right? Now I want to get y all by itself, so I divide both sides by 2, and I got y is equal to negative 3 over 2x plus 11 over 2. All right, so you don't have an answer here, you just have it, so now you can graph it in your calculator. We do the same thing with the other one. So the other equation is negative x plus y equals 3. We're going to add x to both sides, and we got y is equal to x plus 3. Now we can graph in our calculator. to show you how to do that. Hopefully you already know, but if not, here's how we do it. First, your TI-84 might look a little different from mine, but this is still the same stuff, same buttons, right? So I got something in there right now. A good thing, like maybe you're like this has R's in it and all this. If you find that your calculator's acting weird, here's how you reset it. Second plus sign 7, right? Go to reset, and then I want to reset everything, all. So over, and then I'm saying yes, 1, and then yes, reset. So if something's weird with your calculator or you feel like your graphs aren't showing up, do that and that'll fix the problem 9 out of 10 times. So I go to y equals, see, it fixed my issue. And now I graph negative 3/2 x plus 11 halves. So negative, I'm going to do this alpha y equals enter to get this fraction bar and put 3 over 2 and then x, right? I want it to look exactly how my equation looks. 3 over 2x plus, and then I'm going to do alpha y equals enter 11 over 2. I would recommend you get familiar with that. Don't use parentheses with division sign. Use that alpha y equals enter. The other one I got y equals x plus 3. So x plus 3. And then we go to graph. And I see clearly there is one solution. Now, a lot of people are just going to try to, press over and try to get to it. And sometimes you can do that, but I don't ever recommend that. Don't do this. What I'm doing right now, don't do it, because you might think what you got is the answer, but it's probably not, because you can't get but so close. Instead, go to second, and then this trace button. And then we're trying to figure out where they intersect, so 5, right? It says select the first curve. So my cursor's on one curve, I hit enter. It's on my second curve, and by curve, we just mean my graph. Hit enter. And then it says guess. Now I'm going to get my cursor close to the answer. It doesn't have to be right on it, just close to it. And hit enter. And it tells me the intersection is 1, 4, which means that's my solution. All right. My solution for these solution is a point, right? It's the whole point. The point 1, 4. That's the answer. It's not just the x value, it's the x and the y value. Because the question is, where are they intersecting? Well, you don't just intersect at an x value, you intersect at an x and there's a y value. So the solution is some point is solution. So if there is no point to where they intersect, there is no solution. And if there's an infinite amount of points, then there's an infinite amount of solutions. All right, so that's how you do it. I'll show you again. All right, let's try this one. It says elimination method. We're not doing that. We're just doing this by calculator. So we got 3x minus 4y equals 1, and I got 2x plus 3y equals 12, right? Going the same thing, solving for y. That means we subtract 3x on both sides. I like to write my x's first, so mine equals negative 3x plus 1. Divide both sides by negative 4. And that means I'm going to have y is equal to negative 3 divided by negative 4 is positive 3 over 4x. And then 1 divided by 4 would be negative 1/4. All right. For my other one, subtract 2x on both sides, minus 2x, and I got 3y is equal to negative 2x plus 12. Divide both sides by 3, and I got y is equal to negative 2 over 3x. Now, 12 divided by 3 is positive 4, so plus 4. All right. And then I want to find my solution. I go to my calculator and I enter this stuff in. So y, I got y equals 3/4 x minus 1/4, so y equals, clear this out, alpha y equals enter 3 over 4 x plus alpha y equals enter 1 over 4. Be sure that you entered it in right. It was a minus sign, right? Not a plus sign, so I should go to the minus. That's an easy way to get the wrong answer. So with the calculator, you need to make sure you put it in right. Then this next one, negative 2/3 x plus 4. So clear this out. Alpha y equals enter. That's negative 2 over 3 x plus 4. Make sure I entered it in right. Negative 2 over 3x plus 4. All right. Then I go to graph. And once again, I see where they intersect. Now I'm just hitting second, trace, 5. My first curve, enter. My second curve, enter. Guess, I'm getting close to it, and I hit enter. The answer would be the point 3, 2. So, the solution, 3, 2. Simple as that. All right. On to the next. Solving the system once again. So, we got 3x minus 2y equals 4. And we got negative 6x plus 4y equals 7. Solve for y, right? Minus 3x minus 3x. So I got negative 2y equals negative 3x plus 4. Now I divide both sides by negative 2. I got y is equal to negative 3 divided by negative 2 is positive 3/2 x. 4 divided by negative 2 would be negative 2. All right. Same thing with my next one. Add 6x to both sides plus 6x. So this is 4y equals 6x plus 7. Divide both sides by 4. I got y is equal now. 6 over 4 is the same thing as 3 over 2x. Now, 7 divided by 4, I don't know. I'm going to just say plus 7 over 4. Now look at this, right? The last two problems, we could have said we know there's going to be one solution because we have different slopes, right? Different slopes. That, different slope, different slope. But this one, same slope, right? 3/2. Slope here, there. But what we have different is different y-intercept, right? Here and here. We have different y-intercepts. That, when I see that, I already know there's going to be no solution. But maybe you don't know. Maybe you slip up on that. Maybe when you see it, you're like, I'm not sure. So, you go to graphic. So, 3/2 x minus 2. 3/2 x, I'm going to just say minus, delete this, minus 2. And then we got 3/2 x plus 7 over 4. So this is, delete that, 3/2. Delete this, alpha y. And then 7 over 4. All right, we graph. Now, when you look at these, you can kind of tell that they have the same slope, but maybe not. Maybe you're not sure. So maybe you want to hit zoom and say, all right, maybe they intersect somewhere that I can't see. So you zoom out 3. And zooming out from the center. But if you look at it now, you can see that they don't ever hit. If they don't ever touch, then there is no solution. In my opinion, it's better. It's better when you understand the slopes and if they have the same slope and the different y-intercepts. That means that the line, the slope is the same, but the placement is not the same. Where it hits the y-axis is different, so then they'd never cross each other or intersect. It's better to know it that way, but sometimes we don't. All right, the last one I'm going to show you is solving this system. So once again, last example, we got 8x minus 2y equals -4, -4x plus y equals 2. All right, solving for y. Same thing every time. So solving for y. Subtract 8x on both sides minus 8x. So then I got -2y is equal to -8x minus 4. Divide both sides by -2. I got y is equal to +4x, and then -4 divided by -2 would be +2. Right. Over on this other one, I'm just trying to get y by itself, so I add 4x plus 4x, and I got y equals 4x plus 2. Now, surely with these, people look at them and say, hey, man, they're the same exact line. Same line, right? You can see that now. And if it's the same line, of course, when you graph it, it's going to look something like so maybe something like this, the first one, and then you graph the second one, and it also does that. And every point on this thing that they intersect, this point, that point, that point, that point, that point, all these points are solutions, and every line has an infinite amount of points on it. You zoom in, and then it's like here, right? There's millions of points of it. So the answer here is solutions. All right, and that's it. Thank you.